Hello and good evening once again to Haybridge Maths Department, Year 2 Pure, Chapter 3, where we're looking at series, and today we're going to be looking at 3.72, increasing, decreasing, and periodic sequences. So we're looking at these three different types of sequences. So don't forget to make notes, pause after each slide, go through any your turn questions before I go through them, and make sure you get everything down. Okay, let's get started with this. Okay, so here we've got an increasing sequence. As you can see, you've got 2, 3, 4, 5, that's an increasing sequence. 1, 4, 9, 16 is an increasing sequence. Basically, any sequence where the next number is bigger than the one before for any number term in the sequence, then you've got an increasing sequence. It's best expressed, if we just move that page extender button there, like this. This is a formal definition of what I have just said, but an increasing sequence, as I say, it's just each term you go along gets bigger. It is as simple as that. But it has to be for every single term. That is about the only kind of thing that might catch you out on increasing sequences. Not surprisingly, decreasing sequences are the same. So pause, make notes, and then we'll have a look at decreasing sequences. Right, so let's give you an example of a decreasing sequence. So we might have, -3, -6, -9, -12. There you go, there's a decreasing sequence. I'm sure you could come up with some other sequences yourself that are decreasing. The important thing to note is this definition here, which basically is wrong because it says a sequence is increasing. If we just change that to decreasing, the sequence is decreasing if un plus 1 is less than un for all n, where n is a member of the natural numbers. That just means a natural number is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's all the numbers that are positive and whole number. So basically all this is saying is if the sequence is going down and each subsequent term is smaller than the last, no matter how far you go, if you keep on going with it, it's always smaller, then you've got a decreasing sequence. Pause, but before you pause, perhaps you could come up with some examples yourself of decreasing sequences, but then pause, make notes, and then we'll have a look at periodic sequences. Now, periodic sequences are ones which loop round, and it's where it comes back round to where it started again, and you have to keep on doing this big loop over and over again, and you'll get a periodic sequence. So if I put down, say, -2, 1, -2, 1, -2, 1, you get the picture. Now that is a periodic sequence. The only other thing to note about this is the order. Now the order tells you how many terms do you go before the loop starts again. So in this case it's 2, because you just go -2, 1, oh, back to -2. So that's what your 2 goes, 2 terms to get to back to where you started again. You can get sequences with much bigger orders, but on this one you've got order 2. For instance, if you just had a very weird one, if you had 1, 2, 3, 1, 2, 3, 1, well, you get the picture again. This time you've got order 3, and if you had 4, 5, 6, 4, 5, 6, 4, dot, dot, dot. You've still got a sequence of order 3. So, periodic sequences, make sure it does take you back to the start before to count whether your order is. We've got an example coming in a minute where we have to be careful about when it's not just coming back to the number, it's where the sequence starts all over again, and we'll see exactly what we mean in an example coming in a minute. But there's some examples of periodic sequences. Get those down and then get these notes here into your notes as well. Let's just move a page extender there so you can get that bit. But yeah, get that all down and then we'll have a look at some examples. This is rather a short chapter or section of this chapter. Okay, so let's have a look at see. Oh, yeah, this is before we go on to the examples. I should say I forgot this one. This is where we have sequences that are neither increasing, decreasing, or periodic. It's not mutually exclusive. Not all sequences will fit into the increasing, decreasing, or periodic. You get ones that just don't fit any of these. So we might have 1, -2, 3, -4, -5. I don't know how we're generating these terms, but it gives you an example of the fact that sometimes they get bigger, sometimes they get smaller. Doesn't seem to be following an increasing, a decreasing, or a periodic pattern. Okay, so let's have a look now at an example from the textbook. So it's a very straightforward example, I would hope. You've got un plus 1 equals un plus 3, and you've got u1 equals 7. Now, we've seen this previously with the sequences where we iterate. So let's see how this works. So we start, it says u1 is 7. So we start off with that. And then the next term, which is u2, and I'm determined not to make any jokes about that tonight. So 7, then u2 are this awful band that just worse on, sorry, 7, 10, 13, 16, dot, 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 and clearly from that you have that un plus 1 is bigger than un, and it's clearly going to be for all n, therefore sequence is increasing. Nice and straightforward, I hope. So get that down into your notes, press pause, and then I'd like you to have a go at this example. In this example, you've got a different type of sequence. The last sequence here was arithmetic. Here we've got a geometric. You've got to do the same though. It's done through iteration, and have a go at this. Press pause now, and then I will go through it in a few seconds time. Okay, so we've got u1 is a half, a quarter, a 16th, 1 over 256. So each term in turn is getting smaller. So in this case, you've got un plus 1. The next term along is smaller than the previous term. Therefore, and this works for all n, so n, or sorry, the sequence is decreasing. There you go. I hope you got that right. Right, we've got another example here, also from the textbook. You can almost guess what's going to happen here just by the fact that we've used up increasing and decreasing. But let's have a look at this example here. It's not produced iteratively. We just stick in n is 1, n is 2, n is 3, n is 4 to generate our term. So if we stick in 1, then we get u1 is sine 90 times 1, which is sine of 90, of course, is, actually let's just write down sine of 90 is 1. And then u2 sine of 180, well, that's going to be 0. u3 is going to be sine of 3 lots of 90, which is 270, which is negative 1. u4 sine of 360, and that again is 0. u5 sine of 450, which is 1. So you could say, well, that's clearly periodic. It's easy to see it's periodic, but let's have a look at the order. Well, you could say, well, look, 1, 2. It's got an order too, but you have to look at where it actually repeats itself, because if you looked here from this term, it'd go 1, 2. So from here, so you'd go to the 1, 1, 2, 3, 4. So the order is 4. It's not 2, although you've got that 0 there and the 0 here, then you still count from the 1 to the 1, because you know that the next term is going to be 0. The term after that will be negative 1. So the order is 4 and not 2. That has caught out students in the past before. Okay, pause, make notes, and then that's it for examples today. So could you have a go at exercise 3G now? Thank you very much. Goodbye.